Have you ever been to the beach and seen a really large shell on the seashore? Well, not one of those clam shells, but I'm talking about one of the really big swirly ones. When you hold it up to your ear, they say that you're supposed to hear the ocean or the waves crashing in it. Now, this is sort of true. It does make an interesting sound, but it isn't actually the ocean because it's not really a small ocean inside the shell, right? But what's actually happening, because of the shape of the shell, the swirly part, is that it's taking the ambient noise of the air around and it's turning it into something else. Normally our brains tune out that sort of air, that ambient noise of the air swirling around in the atmosphere. So when we hold it up to our ear, it sounds like it's different. But that's because of the shape of the shell. And that's really interesting because we see this sort of effect, this sort of ghost or something that lives within a shape in many other places, especially within technology. What about the times where you've taken a photograph using a really nice lens or maybe even a not nice lens, and it looks like something like a lens flare? Was it a ghost, or is it something that's the result of the shape of the lens as it interacts with the light and when you look through it? So in this video, what we're doing is we're taking technology and we're studying the shape. And by studying those shapes, we hope to understand these ghosts within them. Not just the ghosts, but the way that they experience the world and how we can translate that into something that we can experience too. So we're talking about the shape of technology, the way we're interacting with it, and the environment in which we're interacting with it in. Specifically, we're going to look at the shape of AI machines to understand what they might be experiencing. Is it possible to take that experience and translate it into something that humans can understand? But of course, we're always designing technology to do the opposite. We want machines to understand our experiences so that they can help us better. But how can we understand the experiences of machines as they are today? Can we understand what our phones experience as we're using them? Or can we understand what a toaster experiences while it heats up our bread? Now, it's a little bit difficult to define what a machine experiences, because we don't even understand the experiences of the many living creatures that share our world. In fact, it can even be difficult to understand the experiences of other humans. So how can we call the inner workings of machines, animals, plants, humans, and other things experiences if we cannot understand what it is like to experience them ourselves? But this is exactly what we're trying to explore. We want to use the shape of an AI model, like a seashell we hold up to our ears, to transform what we would normally experience into something that is unique to that AI. Of course, whatever we build, we cannot ever experience what it is like to be a machine, or a shell, or an animal, or even another person. Just like we can never experience what it is like to be a bat. We can only understand what it's like to experience ourselves. But we can do a good job at translating something of that experience into something that we can experience with our own eyes and ears. In this immersive art installation, we introduced some wearable technology, a shell of sorts, that translates aspects of what a trained AI model allocates attention into something that a human can experience with their own built-in shells. The trained model in question is a transformer model, which is a type of neural network architecture commonly used in natural language processing tasks. Transformer models are super famous right now. If you've seen an AI model on the news doing something, like making a really cool photograph, beautiful art, or maybe even a video of, I don't know, some really famous politician doing something completely crazy on a unicorn, then it's probably got transformer technology under the hood. These models are designed to encode relationships between particular elements in a dataset, allowing them to pick up on patterns of elements that occur more frequently together. In the context of language, this means that transformer models are able to recognize relationships between words and phrases and use that knowledge to generate new text or perform other language-related tasks. So in the case of our art installation, we will use the transformer model to analyze input data, such as audio or visual stimuli, and identify relationships and patterns between different elements in the data. The wearable technology will then translate those patterns or relationships into something that a human can experience, such as a change in lighting or sound. Because humans don't really experience all these different layers and numbers and linear algebra, so whatever the machine is doing, we actually have to translate it into something we understand, into human language. That's not really language, but something that our biology can understand. Take a look pun intended, at how the transformer model sees our world. The video feed that people will be seeing while wearing the art piece is obstructed, except for the layers the attention layers are actively processing. This way, participants can only see the areas of vision that the attention layers can see. So to do this, we get a helping hand from our staff farmer Nicholas, who wrote this very nice piece of code for us. So this code does a lot of things, but let me break it down for you. We're using a pre-trained vision transformer model called CLIP, made by OpenAI that helps us associate images and text together in the same shared latent space. Now, how does it work? Well, CLIP takes an image and breaks it down into little pieces, kind of like a quilt, but let's call them patches, like patches on a quilt. Each patch looks at the other patches in the image and figures out which ones are the most important. But there's one patch that's just a little bit different. It's sort of a fake patch because it doesn't represent any of the actual image. Instead, it pays attention to all the other patches equally. And this is the key to how we limit what human users can see. As CLIP is doing its thing and figuring out which words go with which pictures, we extract the attention pattern of that fake patch. This attention pattern tells us which parts of the image are the most important overall, and we use that to limit what the human user can see. It's kind of like putting a spotlight on certain parts of the image and leaving the rest of it in the dark. And that's it for the code. The code does some pretty cool things with computer vision and attention maps to modify a video in real time. Now, what's also cool about this is how this experience is affecting people after they play with it. We want to know what it feels like to directly see and hear these ghosts that the machines are creating and experiencing. We want to know that as they put this sort of shell up to their eyes and ears, how does it make them feel? Is it kind of spooky? Does it make them empathize with machines and give them more moral consideration? We don't know, so that's what we aim to find out. After each participant finishes the experience, we're going to ask them how they feel so that they can describe their experience naturally. No surveys, no nothing like that. We just want them to tell us right after they take off the interactive helmet. We're hoping that these insights will help us understand the manufactured experiences of multiple agents, whether they're human, machine, or a mix of both. So, what kind of ghosts can we find in the machine? Well, what kind of ghosts can we find anywhere else? Experience is such an interesting thing, and we think that it's worth thinking about how we're experiencing different things, but also how other parts of our world are having experiences too. Can we translate these experiences to what we see? Can we modify our own experiences? Can we manufacture experiences? Well, this is stuff that we hope that our art installation will explore and more. Stay tuned to find out more.